We shall now discuss about the spreading codes that are used in WCDMA. So what is WCDMA? WCDMA stands for Wideband CDMA or Wideband Code Division Multiple Access. Now, what is WCDMA? Just to explain very briefly, the cellular communication with respect to third generation, for which the technology that was introduced, one of the technology that was introduced was UMTS, Universal Mobile Telecommunication Service. Now, for this cellular technology, the air interface that was defined is what is your WCDMA. Now, wideband CDMA, because it is, what do we say, an inherent or you can say an upgraded version of CDMA, the whole concept behind WCDMA is based on having a spreading code. So in WCDMA, there are two types of spreading codes that are used. Number one is channelization code, followed by number two, scrambling codes. As far as channelization codes are concerned, these codes are used in order to increase the bandwidth of the signal, meaning that a narrowband signal, when spreaded by a channelization code, will result in a wideband signal. Once the signal has been spreaded using channelization code, it will then further be spreaded using scrambling code. So what are these channelization and scrambling codes? So let's begin with channelization codes. Channelization codes are based on the concept of orthogonal variable spreading factor, which means that whatever codes are generated under the guise of channelization code, they are going to be orthogonal to each other, which means more than one channelization codes that are generated will have a tendency to not interfere with each other. Now, the channelization codes are generated from something called as a code tree. Now, what is this code tree? Now, this concept of a code tree is somewhat extended from the concept of generation of Walsh code. Okay, the rule that is used in the concept of code tree is that when you begin with one particular value, okay, C, it will further result in the formation of, like C being a 1 cross 1 vector, will result further in the formation of a 2 cross 2 vector having the values of C, C, C and minus C. So where you are dealing with a 1 cross 1 matrix, that is going to have a SF of 1. Now what is SF? SF stands for spreading factor. And SF of 1 will result in a spreading code matrix which is having a spreading factor of 2. So where you are having a 1 cross 1 matrix of a single value 1, that will result in a 2 cross 2 matrix with the values 1, 1, 1 and minus 1. If you look at the nature of the code tree, it will only result in channelization code matrices which are in powers of 2. So a 2 cross 2 matrix will result in a 4 cross 4 matrix which has a spreading factor of 4. A 4 cross 4 matrix will result in an 8 cross 8 matrix, which has a spreading factor of 8, so on and so forth. Now, there are certain rules that this particular code tree or the codes that are extracted from this particular tree are expected to follow. For example, if you are assigning one particular code, let's say C of 4, 1 to a particular user, if I want to ensure orthogonality between this particular code and any other code which I'm going to assign to some other user, I have to ensure that whichever code is lying on the path of C4, 1, starting from the root till wherever the code tree extends, should not be assigned to any other connection. Meaning, if I'm assigning C of 4, 1 to one particular user, I'll have to ensure that in order to maintain the concept of orthogonality, I should not be assigning any other user C of 2, 0, C of 1, 0, and C of 8, 2, 8, 3, and wherever the code tree extends. Okay, that is what is expected if you want to maintain orthogonality. Okay. Now, these channelization codes can be used in such a way that different terminals and base stations can operate their code trees independent of each other, which is what I just explained, that when you are assigning one particular code to one user, if you want to maintain the orthogonality, you have to ensure that whichever other codes come in the path of that particular code, whether on the side of the root or on the higher side, should ideally not be assigned to any other user if you want to minimize the interference. Now, how are these channelization codes used? In the downlink, these channelization codes are used to separate the different users within a cell or a sector, which means that from one particular base station, so if one particular base station is currently having multiple transmissions, in order to ensure that the different transmissions do not interfere with each other, it is expected that the codes which we assign to each of these transmissions should be time synchronized. Whereas in the uplink transmission, the same channelization code is used to separate the different services or the physical channels that are being assigned to one particular user. Why? Because in uplink, two mobiles are not necessarily synchronized in time. They will always have a tendency to transmit at two different time intervals. In that case, you may assign the same channelization code to the two different users. This is how the concept of channelization code works. Moving on, next comes the second spreading code, which is called as scrambling codes. Now, one problem one would see in the case of channelization codes, like we just mentioned previously, that in the downlink transmission, channelization codes are normally used to separate the different users within a cell or a sector. What happens if two users from two different cells are assigned the same channelization code? So interference between these two users is bound to happen. This is where your scrambling codes come into picture. So one of the reasons for having a second spreading code, in spite of already having a spreading code in the form of channelization code, is to solve this particular problem. So scrambling codes are normally used in downlink transmissions to reduce inter-base station interference. Ideally, one scrambling code will be used per cell or per sector. Okay, this is to ensure that there is orthogonality between the different downlink channels between the different cells. And just as I spoke few seconds back, we derive the channelization codes from the code tree. However, for one cell, we will have only one unique scrambling code, which means that under one scrambling code, a code tree is basically going to be used for generating the different spreading codes for all the users in that particular cell. Now, in the theory of WCDMA, a typical scrambling code has been defined as either being a long code or a short code. In WCDMA, long codes that are used are called as gold codes. This particular code came into picture due to a scientist by the name Gold who came up with this concept of using gold codes as a scrambling code, which is basically a way. How are they actually obtained? They are obtained by XORing two sequences of same length, let's say M, with each other in such a way that whatever gold codes one will generate, they will always have minimum correlation with their other member sequences. Okay, so that is what your long codes are. And you can also use short codes in WCDMA, which has been defined from a sequence from the family of periodically extended S2 codes. You just need to remember the names of the codes and you don't have to remember how they are generated. So in case of scrambling codes, you are either going to use long code or short code. For long code, you've got gold codes, which are basically used. And for short codes, there is a family of short codes called as S2 codes, which is used if you are going to use them as a case of scrambling code. So in downlink transmission, we use scrambling codes to assign to two different cells so that you can reduce inter-base station interference. In uplink transmission, the same scrambling codes are used to separate the different terminals. So this sums up the concept of spreading codes that are used in WCDMA.